We will continue with equations of motion with constant acceleration. The first equation is v equals to u plus at. The second equation, we have s is equals to ut plus half at squared. And the third equation is v squared equals to u squared plus 2as. Now I'm going to define the terms. V is the final velocity. Final velocity. U stands for initial velocity. A is the acceleration. T is the time taken to travel a particular distance. Here we have S. S is the distance traveled by the object or body. By an object or body. I think that is all we have. So now, I'm going to go ahead and show us how these equations are derived. The first one, v equals to u plus at. You recall that in our previous video, we learned that acceleration is the difference in velocity over time. That means acceleration is equal to a change in velocity over time. And change in velocity is final velocity minus initial velocity. That will give us the difference in velocity over the time taken. So from this equation, if we cross multiply, we have v minus u is equal to 80. So we make v subject to the formula. So we have 80. U comes to this other side, it comes plus u. And that gives us the first equation. So the first equation of motion. Newton's first equation of motion. I hope that is well understood. So now we move on to the derivation of the second equation. S is equals to ut plus half at squared. You recall that average velocity is equals to final plus initial velocity over 2. It's very simple. When you are asked to find the average of something, you add those things together and you divide it by the total number. So the same thing is applicable here. You add the two velocity, which is the final and the initial velocity together, and divide it by 2. This will give us our average velocity. So, average velocity equals to v plus u over 2. But we recall from the first equation, that v is equals to u plus 80. So let's just start this. Now we substitute this equation in here. So substitute, let me call this equation star, while this is star star. So substitute equation star star into equation, this equation, I call it star. Alright, so we have average velocity is equals to V is equals to U plus 80. So I'm not going to write U plus 80 as my V plus U all over 2. Okay? So U plus U, average velocity is equals to 2U plus 80 all over 2. So I have this as my average velocity, and I can still go ahead to divide both as what I have here. This cancels this, so I have U plus half 80. So my average velocity is equals to U plus half 80. Now let's move a step further. We remember that average velocity or speed, average velocity from our previous lesson, you can recall that average speed or average velocity is equal to distance over time, the distance traveled over time taken to cover that distance. So we have average velocity equals to distance is represented as x over t. So if we cross multiply, our distance is equals to average velocity times time. So now we substitute the value of our average velocity into this equation. So we have s equals to u plus half 80, which is our average velocity here, times time. So we have this ut. I hope you know that this t multiplies this, and at the same time it multiplies this. But a better way to write it is this way. So u times t will give us ut plus half 80 times t will give us half 80 squared, which leads us to our second equation of motion, s equals to ut plus half 80 squared. I hope that is explanatory enough. We will be learning how to derive the third equation of motion. The third equation is v squared equals to u squared plus 2as. Now we'll make use of the first equation of motion. You remember our first equation, which says v equals to u plus 80. Now, making use of this equation, we are just going to square it. Square both sides of the equation. Of the equation 1. So we have v squared equals to u plus 80 squared. Alright? So v squared equals to u plus 80. This is the same thing as writing it twice. U plus 80 in two places. So now v squared is equals to u times u will give us u squared. I'm trying to open the bracket here. So u times 80, that will be u80 plus 80 times u, that will be u80 also, plus 80 times 80. That will give us a squared t squared. Or 80 squared. So we have u squared plus 2u80 plus a squared t squared. So from here, we are just going to factorize. We factorize these two. So by factorizing, we have v squared is equals to u squared plus, we factorize this, we have 2a is common to both sides. So 2a times ut will give us 2u80 plus, this will be half at squared. How do I come about that? If we multiply this by this, this is what we have. Let's check it out. 2a times half at squared. We want to see if this will give us a squared t squared. So this cancels this. So we are left with a times a, which is a squared t squared. Alright. I hope you can see that. So quickly, if we recall, from the second equation, we learned that distance is equals to ut plus half at squared. So we substitute this into this equation. So anywhere we see ut plus half at squared, we replace it with s. So substitute s into the equation above. So I have hence, I have v squared is equals to u squared plus 2a s. The whole of this becomes my s. And this gives me the third equation of motion. I want to believe that is very, very explanatory. Now we will be solving calculations involving Newton's equations of motion. Here we have this first example. A body starts from rest and accelerates uniformly at 5 meters per second squared until it attains a velocity of 25 meters per second. Calculate the time taken to attain this velocity. This is a why question. Okay, before I move on, I'd like us to take note of 3 things. Now, when a body starts from rest, a body moves from rest. From rest, that means the initial velocity u will always be 0. Take note, when a body moves from rest, initial velocity u will always be 0. Also, when a body comes to rest, that means it stopped, then we're talking of the final velocity, v equals to 0. So let's take note of this.
So from our question here, your body starts from rest. Start or move from rest. Initially, the body was static. So that means our initial velocity is 0 and accelerate uniformly at, we have this 5 meters per second from rest. Sorry, this is 5 meters per second. This is our initial velocity. Our acceleration is 5 meters per second squared until it attains a velocity of 25 meters per second. That is our final velocity. V is equal to 25 meters per second. So the question says, calculate the time taken. Calculate t. We don't know t to attain this velocity. Okay? So the first thing we need to do here is to list the 3 equations of motion, after which we decide which one of them to use, depending on the given parameters. So we have v equals to u plus at, which is the first equation, s equals to ut plus half at squared, and third one, u squared plus 2as. So with this, let's find out which one of them will be applicable. So from our question here, we have v we have v to be 25 meters per second. So we have our v, we are given v. Do we have t? No, we are looking for t. Do we have u? We have u. We have a. So we look for t. Now let's move to the second equation. I'm just going to do first and second. We compare which of them we are to use before we move on. So for the second one, s. Do we have s, which is distance? No, we don't have it. Do we have u? Yes. Do we have t? No, we don't have it. So since for equation 2, we already have 2 unknowns, 2 parameters that are not unknown. Because of that, we can't use equation 2. Unlike equation 1, where we have just one parameter, which is the time taken, that is unknown. So I'll go with this. So we have v equals to u plus at. This is the equation that we'll be applying. Our v is 25 meters per second. This is our v, which is 25 meters per second equals to u. Our u is 0. Our a is 5 meters per second times t. T is unknown. This is a, this is o. Okay, so from here, this multiplied by this, 5 times t will give us 5t meters per second. Sorry. So from here we have 25 meters per second plus to 5t meters per second. As I mentioned, don't make a mistake, it's meter per second squared. So from here we divide both sides by 5 to make our t stand alone. So we have 25 meter per second equals to 5t meter per second squared. Divide this side by 5. Divide this side by 5. 5 cancel 5. This here 1, this here 5. So we have t. Of course, the formula is the unit is still there. So we have t meter per second squared equals to 5 meter per second. Now I just want t. I don't want the unit. So that means I'm still going to divide both sides by this unit to make t stand alone. So t is equals to, this is 5, of course 5 divided by 1 is 5. So meter cancels meter, seconds, we have this cancels this. So I have t equals to 5 seconds. So here is our answer. So the time taken to obtain this velocity is 5 seconds. I hope that is clear and explanatory enough. So here is another example. A body starts from rest and accelerates uniformly at 5 meters per second. Take note, acceleration. I'm just going to go ahead and write out our parameters. Acceleration is equals to 5 meters per second squared. But before then, we were made to understand that a body starts from rest. Starts from rest. Start, the word start tells us that this is the initial velocity from rest. Implies initial velocity is equals to 0. So calculate the time taken by the body. We are asked to find t to cover a distance of 1 kilometer. We're giving our distance to be 1 kilometer. Okay, before we move on, distance given here is 1 kilometer. So we need to convert it to meters. And to do that, 1,000 meters equals to 1 kilometer. So we have 1,000 meters. Okay, so we list out our equations of motion. As usual, in order to decide which one of them will be best for this question. Okay, so we have A. The first one, yes, we have A. U. We have U. T, yes. Do we have V? No. We don't have V. Okay, I'm just going to use this. We don't have V. Now for the second one, let's check the second one. S. Do we have S? Yes, we have S. Do we have U? Yes. We have U. Do we have a T? Okay, we're looking for T. Good. A. Do we have A? Yes. So we are looking for T. For the first one, we are not looking for V, but we do have V. We are not asked to find V. So if you ask me, I will prefer to use the second equation because it fits perfectly with the question. Since we are asked to calculate time, and that's exactly what we're left with. So using equation 2, s equals to ut plus half at squared. Our s is 1000 meters, u is 0, t we don't know, plus half. Our a is 5, and then t squared. So from here we have 1000 meters equals to 0 times t will give us 0 plus 5 t squared over 2. So from here, I have 5t squared. Of course, this 5 is carrying meter per second squared because it's acceleration. So when we cross multiply, we have 5t, or better still, I can write 5 meter per second squared and t is equals to 1000 meters times 2. This will be equal to 2000 meters. So now I want t to stand alone. That means I'm going to divide both sides by 5 meter per second squared. I want t, I'm trying to make t the subject of formula. That means every other thing attached to t will be divided by both sides. So this cancels this. 5 here 1, 5 here is 400. 0, 0. So meter cancels meter, and then I'm left with t is equals to, oh sorry, this is t squared, not t. T squared from here. So I have t squared is equals to 400. From here, we have 400 s squared. If this comes up, the minus disappear. So we have 400 second per second squared. So to make t stand alone, we square both sides. Find the square root of both sides, and that leaves us with t is equals to square root of 400, which gives me 20. Square root of 400 is 20, and the square root of second squared is 20. So our time, the time taken to cover the distance of 1 kilometer is 20 seconds. You can see it's very simple. The last question we'll be considering is this. A car moving with a speed of 90 kilometers per hour. Speed, we use it interchangeably with the velocity. So you can as well say this is our velocity. Was brought to rest. This implies the final velocity, while this is the initial velocity. So our u is 90 kilometers per hour, while v, brought to rest, is 0. Remember what I told you earlier? By the application of the brakes in 10 seconds, That's the time taken, 10 seconds. How far did the car travel after the brakes were applied? How far? That means we are asked to find the distance. Distance is what we're looking for. Alright? So like we always do, we write out our equations of motion. So we compare it with the parameters to know which one is applicable. Well, here you observe that our initial velocity is in kilometer per hour. So first we need to convert that to meter per second. So we need to convert this to meter per second. So convert 90 kilometer per hour to meter per second. We have 90 times 1000 . I'll just write it up here. So I have 90 times 1000 divided by 60 times 60. This cancels this. This cancels this. So I have 900 divided by 6, which will give me, 900 divided by 36. 6 times 6, 36. And this will give me 25 meters per second. So we are good to go now. Having done this, we move on by comparing our parameters to what we are given. So with the first equation, V, we have our V, U, we have our U, A, we don't have A, we have T. Now we are asked to find the distance. If we are to use the second equation, which is distance, that means we don't have A and we don't have S. So that will not be the best thing to do. Then let's move to the third. We have U, we have V, we don't have A and we don't have S. So that means we can't use second nor third. So we may need to use the first one, which will help us to find our acceleration, after which we can now go on and use the second or the third equation to find the distance. So V equals to U plus AT. Our V is 0. U is, we just did that. That's 25 meters per second plus acceleration. That is what we are about to find. And our T is 10 seconds. I'll just write 10 seconds acceleration. 10 seconds times A. That's our acceleration. So how 0 equals to 25 meters per second plus 10 A seconds. Please don't be confused. Now from here, I'll have 25 meters per second equals to, I'm going to have minus 10 is equals to 25 meters per second. So I want my A to stand alone, so it means I'm dividing both sides by minus 10 seconds. So A acceleration equals to minus 2.5 meters per second squared. So here is our acceleration. But don't forget we are asked to find the distance, how far. So going back to our equations, we can either use the second or the third to find our distance. So let's use the third equation. Using the third equation, v squared equals to u squared plus 2ax. So our v squared now 0, u squared, what we just did now, squared plus 2 times this minus 2.5 s. So 25 squared, that's 625. This will give us minus 5. Minus 5s. So from here I have 5s equals to 625. Divide both sides by 5. 5 here 1, 5 here 1, 25. Therefore, our s is equals to 125 meters, which is the distance. And that answers the question, how far did the car travel after the brakes were applied? So after the brakes were applied, the car traveled 125 meters. I hope that is well explanatory. And that would be all on calculations involving Newton's equations of motion.